Good day. Today I will discuss the variable valve timing. Background theory of variable valve timing. The valves within an internal combustion engine are used to control the flow of the intake and exhaust gases into and out of the combustion chamber. The timing, duration, and length of these valves events has a significant impact of an engine performance. Without variable valve timing or variable valve lift, the valve timing is the same of all engine speeds and conditions. Therefore, compromises are necessary. An engine equipped with the variable valve timing actuation system is freed from these constraints, allowing performance to be improved over the engine operating range. Piston engines normally use valves which are driven by camshafts. The cam open and the valves up for the certain amount of time during each intake and exhaust cycle. The timing of the valve opening and closing relatively to the position of the crankshaft is important. The camshaft is driven by the crankshaft through timing belts, gears, or chains. An engine requires large amount of air when operating at high speeds. However, the intake valves may close before enough air has entered each combustion chamber, reducing performance on the other hand. If the camshaft keeps on the valves open for longer periods of times with the racing cam, problems start to occur at the lower engine speeds. Opening the intake valve while the exhaust valve is still open may cause unburnt fuel to exit the engine. Performance and increased emissions are according to the engineer David Bizard book, Building Horsepower. When both intake and exhaust are open simultaneously, the much higher pressure exhaust pushes the intake charge back out from the cylinder, polluting the intake manifold with exhaust in worst cases. After multi-valve technology become standard in engine design, variable valve timing becomes the next step to enhance engine output, no matter power or torque. As you know, valves are activated the breathing of the engine. The timing of breathing, that is, the engine of intake and exhaust, is controlled by the shape and phase angles of cams. To optimizes the breathing, engine requires different valve timing at different speed. When the rev increases, the duration of intake and exhaust stroke decreases so that the fresh air becomes not fast enough to enter the combustion chamber, while the exhaust becomes not fast enough to leave the combustion chamber. Therefore, the best solution is to open the inlet valve earlier and close the exhaust valves later. In other words, the overlapping between intake period and exhaust period should be increased as rev increases. Without variable valve timing technology, the engineers used to choose the best compromise timing. For example, a van may adopt less overlapping for benefits of low speed output. A racing engine may adopt considerable overlapping for high speed power. An ordinary sedan may adopt valve timing optimized for mid-rev so that both the low speed drivability and high speed output will not be sacrificed too much. No matter which one, the result is just optimized for a particular speed. Variable valve timing. And in internal combustion engines, variable valve timing or VVT is the process of altering the timing of the valve lift event, and this is often used to improve performance, fuel economy, or emissions. It is increasingly being used in combination with variable valve lift system, and there are many ways in which this can be achieved, ranging from the mechanical devices to electro-hydraulic and camless systems. Increasingly, strict emission regulation are causing many automotive manufacturers used to use BVT system. Purpose of BVT. For a combustion engine to generate power, air must enter and exhaust gases must exit the cylinder chamber. The opening and closing of these intake and exhaust passages are controlled by valves, known as intake and exhaust valves respectively. Without variable valve timing, the intake and exhaust valves would operate in the same manner regardless or the engine's RPM, speed, or the driving environment. This isn't ideal, as the driver may want a different behavior from the engine through a rev range. For example, at high RPMs, the driver may desire more power while fuel economy may be the priority at low RPMs with lighter engine loads. Variable valve timing enables these different behaviors by changing how the intake and exhaust valves work at different engine speeds. Thus, it helps optimize the engine's performance whilst also improving fuel economy and emissions. Valve timing. To understand valve timing, let us take you back what are camshafts. Here, in example terms, camshafts are responsible for the opening and closing the valves. Number 1. And the valves are like the doors for the ports from which the air fuel mixture enters from the intake and exits the chamber from the exhaust valves. 2. With that clear, let's move to the valve timing. As said earlier, the cam or the lobes of the camshaft control the opening and closing of the valves. 3. They ride the valves at definite intervals and with utmost extreme precisions. Number 4. For you to know, the valve timing is measured in degrees that corresponds to the piston's position inside the combustion chamber. And number 5 is the defining the valve timing of an engine is one of the most typical process. The valve timing process. Not going into the detail, here is a brief about valve timing. But before doing so, here are some technical terms used in the automotive world. TDC or top dead center, when the position is at its topmost position or topmost position. And BDC, bottom dead center, is when the piston is at lowest position. Firstly, the inlet valve opens to let the air or air-fuel mixture enters the combustion chamber. These valves open a few degrees before the piston reaches TDC. This is when the engine is about to complete its exhaust stroke. Number 2, the inlet valve closes after the piston reaches tad bit further than the BDC. The piston's movement from the BDC to the TDC creates a vacuum inside the combustion chamber, forcing the air or air-fuel mixture to enter, also called the suction stroke. Number 3, the inlet valve closes just before the compression stroke. This is when both valves are shut. If the engine is fuel injected, the fuel is atomized inside the combustion chamber before the piston reaches TDC, and then fuel is ignited in spark ignition system. This also depends on the ignition timing. Let's save the ignition timing for the some other day. Number 5. Number 4. Coming back to the valve timing, the exhaust valve opens way before the piston reaches the BDC after expansion stroke or power stroke. Now, through BDC to all the way up to a few degrees more than TDC, the exhaust valve is open, which it closes, and the cycle repeats itself stroke after stroke. Special condition in valve timing. Now, the questions comes by, isn't the intake and exhaust valves opening and closing in sync with the pistons TDC and BDC? And why the TDC, both the valves are open for some duration? The reason lies is that three crucial factors called blowdown, overlap, and ramp effect. the blowdown. Both the valves remain shut to perform the combustion process efficiently during the compression stroke all the way up to the power and or expansion stroke. Blowdown is the process where the exhaust valves opens before the piston reaches the BDC. This releases the excess pressure from the combustion chamber. This also confirms that there is no other pressure exerting on the piston during its motion to BDC. Repeat, the exhaust valves were to remain closed till the BDC. Some engine power had to wasted in order to assist the piston to move from BDC to the TDC. Overlap. In the diagram, it is very prominent that when the piston reaches TDC and the exhaust stroke, both the valves, intake and exhaust, are open. This is no way a manufacturing fault, and the opening of the intake valve slightly before TDC and closing of the exhaust valve later after TDC is deliberately done. This is to assist in the pulling the fresh charge from the intake manifold into the combustion cylinder, just like the siphon effect. Not doing so can cause some burnt exhaust gases to remain inside the combustion chamber and dilute the air and fuel mixture. Ram effect. This is the situation where the intake valve closes at a few degrees after the BDC. Like the others, this is also intentionally done to let in more air into the combustion chamber. This is a physical phenomenon wherein a large amount of air entering the cylinder rapidly cannot stop itself. In simple terms, the air is rammed inside the combustion chamber. This is why high revving engines tend to keep the intake valve open for a longer duration to let the air in. But this is not so prominent at low speeds, and the pistons will push some of air out of the cylinder. That's all. Thank you po.